Welcome to the tutorial over 6.7, Solving Radical Equations and Inequalities. Your new vocabulary is radical equation, extraneous solutions, and radical inequality. Your first key concept is the steps to solving radical equations. So for step 1, we're going to isolate the radical on one side of the equation. Then we're going to raise each side of the equation to the power equal to the index of the radical to eliminate the radical. So basically, if I have a cube root on one side and then I have just a number on the other side, I'm going to cube this side and also cube this side because my index, which is right here, is a 3. Then we're going to solve the resulting polynomial equation and check our results. So in this case, we would have 3 cubed, which is 27, and then on this side we just have an x, so x equals 27. Now we have to check our results by putting this back into our original equation. So the cube root of 27 equals 3. So the cube root of 27 is 3, 3 equals 3, so that's a solution. Okay, so here's our first example. We're going to solve the square root of y minus 2 minus 1 equals 5. So what we're going to do is isolate the radical, so we have to get this expression by itself first. So what we want to do is add 1 to both sides, and that's going to give us the square root of y minus 2 equals 6. Now we're going to raise both sides to the power of our index, which is a 2 for square root. So we're going to square this side, and we're going to square this side. So we're going to have the squares cancel. The squares cancel each other, so we're just going to have a y minus 2 equals 6 squared, which is 36. Now we can add 2 to both sides, and we get y equals 38. Now, this is only half of the way through. Now we have to make sure that we always put this answer back into our original equation and solve to check and see if it works. So we're going to check. So we're going to have the square root of 38 minus 2 minus 1 equals 5. So the first thing we can do is, on the inside of the radical, we can combine those two. So we're going to have the square root of 36 minus 1 equals 5. We know that the square root of 36 is 6, minus 1 equals 5. 6 minus 1 is 5, equals 5. So yes, that is our answer. So y equals 38 is the answer to this radical equation. Okay, our next example, example 1b, we're going to solve the square root of x minus 12 equals 2 minus the square root of x. So the first thing that we have to do is get the radicals by themselves. We're going to isolate the radicals. So our first step is we're going to want to square both sides so that we can get rid of the square root on this side of the equation, and then we'll have to square this out also using FOIL. So we're just going to, when we square both sides, we're going to get x minus 12 equals 2 minus the square root of x squared. So we have to FOIL this out. So we're going to have x minus 12 equals, instead of writing the squared here, I'm just going to write it out twice. So 2 minus the square root of x. So now I'm going to do the first times the first, which is 2 times 2 equals 4. Then I'm going to do the outsides. So 2 times the negative square root of x is negative 2 square roots of x. Then I'm going to do the insides. So then I'm going to have another negative 2 square roots of x. And then I'm going to do the last. So negative square root of x times negative square root of x is positive x. Now I have x minus 12 equals 4 minus, we're going to combine these two middle terms, so minus 2, or a negative 2 minus 2 is negative 4 square roots of x plus x. So now we need to get our radical by itself. So this is all still the first step. We're going to subtract x from both sides, and then we're going to subtract 4 from both sides. And then that's going to give us, sorry, that's supposed to be a 12. Our x's are going to cancel, and then a negative 12 minus 4 is going to give us a negative 16. So negative 16 equals negative 4 square roots of x. Now we're going to divide by negative 4 on both sides, and that's going to give us a positive 4. Equals the square root of x. Now, in order to get our x by itself, we have to square both, or we have to raise both sides by our index. So in this case, it's a squared, so we're going to square both sides. So 4 squared is 16 equals x. Now, we're only halfway done. We still have to check. So we're going to plug in our x equals 16 into our original equation and see if it equals. So we're going to have the square root of 16 minus 12 equals 2 minus the square root of 16. So 16 minus 2 equals 4. So we're going to have the square root of 4 equals 2 minus the square root of 16. The square root of 4 is 2. The square root of 16 is 4. So 2 equals 2 minus 4. Now we see that 2 equals negative 2, because 2 minus 4 is negative 2. Now those do not equal each other. So we see that this solution, since it does not check, there is no real solutions for this equation. Example 2, we're going to solve 3y plus 1 to the 1/3 power plus 5 equals 0. So we know that the 1/3 power is the same as the cube root. So we're going to take the cube root of 3y plus 1, and I'm just rewriting this, plus 5 equals 0. So instead of writing to the 1/3, we can rewrite this as the cube root, just like I did here. So now what we're going to do is we're going to isolate our radical. So we have to subtract 5 from both sides. So we're going to get the cube root of 3y plus 1 equals negative 5. Now we're going to cube both sides because we're going to raise it to the power of our index. And then that's going to give us 3y plus 1 equals negative 125. Now we're just going to solve like normal, subtract 1 from both sides. 3y equals negative 126. Then we're going to divide both sides by 3, and that's going to give us y equals negative 42. Again, we're only halfway done. We still have to go through and plug this back into our original equation. So we're going to check. We have 3 times negative 42 plus 1 to the 1/3 power plus 5 equals 0. So on the inside here, we have 3 times negative 42. So that's going to give us negative 126. We're going to add 1, raise it to the 1/3 power, add 5 equals 0. So negative 126 plus 1 gives us negative 125. And we can rewrite the negative to the 1/3 power, we can write that as the cube root of. We're going to add 5, and that equals 0. Now finally, we're going to take the cube root of negative 125, and that's going to give us negative 5. We're going to add 5 equals 0. Negative 5 and positive 5 do cancel, so we do get 0 equals 0, and that's correct. So y equals negative 42 will be our answer. Example 3, what is the solution of 7 times the 6th root of 5m plus 4 minus 4 equals 10? So what we have to do is solve for m here. So step 1 is to isolate our radical. So we have 7 times the 6th root of 5m plus 4 minus 4 equals 10. So we're going to add 4 to both sides first. And that's going to give us 7 times the 6th root of 5m plus 4. Sorry about the bell. Okay, so then that's going to give us 14 on this side. Now we have a 7 times everything in the front, so we're going to divide both sides by 7. And we're going to get the 6th root of 5m plus 4 equals 2. Now, step 2 says we have to raise both sides to the power of our index. So we're going to raise both sides to the 6th power. So that's going to give us 5m plus 4 equals 64. Now we're going to subtract 4 from both sides. 5m equals 60. And then we're going to divide by 5 on both sides. So m equals 60 divided by 5, which is 12. So again, we always have to go back and check. So we're going to plug it back into our original equation. So we have 7 times the 6th root of 5 times 12 plus 4 minus 4 equals 10. So we're going to go ahead and underneath the radical, we're going to combine all those values. We're going to solve for that first. So we have 7 times the 6th root of 5 times 12 is 60. We're going to add 4, parentheses, minus 4 equals 10. So 7 times the 6th root of 60 plus 4, which is 64, minus 4 equals 10. Now, the 6th root of 64, if you put that in your calculator, is going to give you 2. So we have 7 times 2 minus 4 equals 10. 7 times 2 gives us 14 minus 4, sorry, not 5, equals 10. Now we have 14 minus 4 is 10, so 10 does equal 10. So this m equals 12 is our answer. All right, our second key concept is going to be the steps to solving radical inequalities. So step 1, if the index of the root is not even, so if this value here is not even, then we're going to identify the values of the variable for which the radicand is not negative. So under here is positive. I'm sorry, I said if the index was not even, it's when the index is even. And then step 2, we're going to solve the inequality algebraically, so just like we've been doing before. And then step 3, we're going to test our values to check our solution, just like everything we did before, except for this time our first step is to make sure that the index of the root, if it is even, then we're going to identify the values of the variables for which the radicand is non-negative. Okay, example 4, we're going to solve the square root of 3x minus 6 plus 4 is less than or equal to 7. So since we have a square root, since this number in front is supposed to be a 2, since that is even, we have to make sure that we find all the values that make the inside non-negative. So we first have to set 3x minus 6 greater than or equal to 0 because that will make it positive. So we're going to solve that to identify the values of x for which the left side of the inequality is defined. So we're going to add 6 to both sides. So 3x is greater than or equal to 6. Then we're going to divide by 3. So x is less than or equal to, I'm sorry, I was writing less than or equal to. That's supposed to be greater than or equal to. 6 over 3 is 2. So x is greater than or equal to 2. So those are the values of x that are going to give us a non-negative in our radical. Now we need to solve our equation. So we're going to have the square root of 3x minus 6 plus 4 is less than or equal to 7. So we're going to subtract 4 from both sides, and we're going to get the square root of 3 plus negative, the square root of 3x minus 6. That's supposed to be an x up there. It's going to be less than or equal to 3. So now we have to raise both sides to the power of our index, which is a 2 here. So we're going to square both sides. Our square and our square root cancel. So we're just going to have 3x minus 6 is less than or equal to 9 because 3 squared is 9. Now we're going to add 6 to both sides. 3x is less than or equal to 15. And now we're going to divide both sides by 3, and we're going to get x is less than or equal to 5. So now our answer is going to be x is greater than or equal to 2, but less than or equal to 5. So the way we're going to write that out is x is greater than or equal to 2, but is less than or equal to 5. So make sure you have this all written down because I'm going to clear it all so that I can show you how to check this kind of answer. So to check this type of answer, we can just say f of x equals our equation on this side. So the square root of 3x minus 6 plus 4. And we can put this into our calculator and we can make a table of values, or you can just do it by hand. So since we know that our solution is 2 is less than or equal to x is less than or equal to 5, we're going to pick a value that's smaller than 2, in between 2 and 5, and then greater than 5. So let's just say that our numbers are going to be x equals 1, x equals 4, and x equals 6. So now we're going to plug in these values to our equation that we wrote, and we're going to see if they satisfy our original equation. So we're going to have the square root of 3 times 1 minus 6 plus 4, the square root of 3 times 4 minus 6 plus 4. Then we're going to have the square root of 3 times 6 minus 6 plus 4. Alright, so when we plug all these into our calculators, this is what we get. So on our first column, where x equals 1, the square root of a negative 3 gives us an imaginary number. It's not real, so we know that that is not going to satisfy our inequality. So we know that it's definitely not 1, so that fits with our bounds that we found. So now we're going to go with a 4. So that equals about 6.45. So whenever we go back to our equation that our inequality that we originally had, we would put this in as 6.45 is less than or equal to 7. And since that is true, we know that 4 is in our bounds, which fits with what we said to begin with. So now we're going to go to our 6. When we put that in, we get roughly 7.46. And when we put that back into our inequality, it's saying that that is less than 7, but it's actually not, so that is not a true inequality. So this does not satisfy our original inequality. Therefore, our bounds are going to be x is greater than or equal to 2, but less than or equal to 5. So this up here is, in fact, our answer. All right, and that is all for today's tutorial over 6.7, solving radical equations and inequalities.